Hi everyone, welcome you back for the session on the vibration control through shape memory alloy. Now in that we are dealing with respect to the second option, the experiment to examine the frequency response of the nitinol wire supporting a weight at the end of the cantilever beam. A schematic diagram shows the cantilever beam to the now even in the cantilever beam also there are two different ends will be there. One is a free end, another one is a fixed end. In the free end, the load is freely suspended. The load which has been suspended freely is through by the nitinol wire. This nitinol wire is actuated by the heat or it may be a temperature phase, by which automatically the vibration will take place, and also the beam will start vibrating and the frequency responses are recorded. Nitinol wire is with a steel beam supported with a weight W and a cantilever beam is as shown in the figure. The suspended wire which is heated in a square wave condition. The generator whose output is varied out the frequency range, and the altering the heating and as well as the cooling of the wire causes the oscillation of the oscillating force, imposing the beam to resonance and produce the vibration. The three resonances were observed with a highest frequency of 168 Hz. The amplitude of vibration would be increased by applying a forced cooling to the wire. Next case is with respect to the cantilever beam exciting using a nitinol wire at the root of the beam. Now in the second phase, nitinol wire is fastened to the beam, and the beam which is a fiber reinforced plate beam or normally a fiberglass reinforced resin beam with a uniform cross section. The nitinol wire is mounted in a V configuration on the center of the axis, the upper surface of the beam. The wire was electrically excited on the first bending models, and the beam was detected at 10 Hz. No other response were detected. The static deflection of the beam was observed when the wire was heated by a DC current. This demonstration that the cantilever beam would be exciting into a resonance by the SMA generator axial force. This schematic diagram shows the cantilever beam. This cantilever beam is made up of the FRP, the fiberglass reinforced plastic molding. Now here in the previous cases, in the first case the entire beam is supported with the nitinol. In the second case, the nitinol wire is hanged at the free end. The third case is the nitinol wire is fixed at the fixed end in the form of a V shape, where the stretching and as well as the expansion and because of the expansion and the contraction of the nitinol wire, because of the heat phase or it may be heat changing, the beam will start vibrating it. These vibrations are recorded, and then that it is said to be somewhere around 10 Hz. Now the vibration control of the cantilever beam using the nitinol wire forcing the element at the root of the beam. Now even here also the same case as that of the previous one, but at the root, instead of having the uniform cross section, a small cutout has been made where the piezoelectric PZT or the piezoelectric crystal or piezoelectric transducer is also fixed to along with the nitinol wire. The vibration control of the cantilever beam using the nitinol wire forcing element at the root of the plate, where the test configuration used is of the FRP with a thin section. The piezoelectric crystal was mounted on each side of the beam at the naked section. One created a forcing drive and another for the measuring of the beam vibration or maybe the deflections. The nitinol wire is arranged in a reconfiguration axially oriented at the root of the beam on the upper surface with a PZT forcing element. Both SMA wire and the forcing element PZT were energized by a two separate variable frequencies power source. The phase relationship between the SMA and as well as the PZT may be in phase or it may be in out phase. If it is in phase, then the frequency it will be multiplied. If it is out phase, the automatically the frequencies it won't be the multiplied or it won't be added up. When the beam is excited by the SMA wire heating and the cooling of the first mode frequencies were observed somewhere around 35 Hz. When it is excited by the PZT crystal, it is observed as 32 Hz. This indicating the system was being detuned by change in stiffness. The PZT drives set at 32 Hz, the amplitude of vibration was significantly reduced when the SMA wire was found to be tightened by PCET. Then the both PZT crystal and as well as SMA wire were excited in phase and the amplitude of vibration was higher than the forcing element, which is nothing but alone by using the SMA, which is 35 Hz, or by using the PZT, which is somewhere around 32 Hz. The opposite condition is prevailed when the PZT crystal and as well as SMA crystals were in out of phase. The amplitudes were much smaller, indicate nearly a total attenuation or actuation. The next set of experiment is with respect to the cantilever beam excited using a commutator input signal to a multiple nitinol wire. In order to demonstrate the frequencies of the bandwidth increases by using a multiple wire energizing through a commutator. The nitinol wire were mounted on a GFRP beam. The root of the beam had an aluminum insert. The nitinol wires were arranged in pair with a spring at one end of the beam to take up the wire slack. When the wire is in cold and to prevent the overchange, the beam response were calculated approximately 3 Hz. The wires were energized through the commutator. This is a schematic diagram shows the beam over which the two set of wires were fixed, the SMA wire 1 and as well as SMA wire 2. These two wires are energized by using a DC power supply. This is nothing but by using a commutator, the frequency controlling it can be done. The dynamic tension of the wire was measured with the sensor and the beam strains were measured by the PZT strain measuring crystals at gauge. Thus, the successful demonstration shows that SMA excitation of the structure frequencies above the maximum for a given wire size detected by the thermal response. These experiments demonstrated a various ways of SMA can be using as an active or a passive control vibrations when these materials are incorporated in the structural applications. As you know that the SMAs are having a major application with respect to the structures. It means that these SMAs it can be used as a vibration controller in the structure when the structure is forced to vibrate either by means of a seismic waves or by means of earthquake waves. The next part is with respect to the multiple embedded nitinol actuators. In many of the applications, the response time of the SMA actuator is limited by heat transfer. Very rapidly heating can be achieved, but the cooling need time. Even in any of the material, the heating is faster, the cooling it will be of the slower. The cooling is long when compared to to a vibratory period of the typically mechanical or it may be a civil structures. The unique approach has been found suitable to overcome this limitation. This approach is based on using a several nitinol wire as an actuator, which is the same thing which has been discussed in the previous experiment. In the parallel and energizing a subsequent of this during a successive cycle of structural motion, effectively reducing the control for the increased frequency response. Now this with a array the actuators an effective bandwidth can be achieved that demonstrate to a greater than the bandwidth as possible as that of a single actuator. See here in this case, by using the multiple strands, the actuator, the nitinol wire 1, nitinol wire 2, nitinol wire 3 and nitinol wire 4, and even with respect to the actuation of the signal by a commutator is varying it. Varying the time of the actuation is also varying it. Once if the time of the actuation is also varied, automatically even the cooling is also varying it, by which automatically the actuation or the vibration attenuation for the structure can be achieved very easily. Now the application of the shape memory alloy. The application of the shape memory alloy is same as that of the smart material. The unique property of the shape memory material which is resulting in a thermally induced phase transformation and a super elastic behavior due to the stress induced phase transformation have been exploited a commercial application on the variety of products. Now the popular applications are the window latches that can overcome open and as well as the closes, the shower spring which are activated above a certain temperature to shut off the water and as well as the heater. The eyeglass frame normally it will be affected by means of so many parameters. Once if it starts falling the eyeglass frames will get damaged. This frame, once if it is damaged also, that it can be recovered by using the shape memory alloy, which is nothing but a original shape. The blood clot filters, even the circuit boards or cryofits, couplings for the repair of the oil lines in the case of the emergencies. See, even in the case of the blood filters, by changing the dimensions of the nitinol plate, by changing the dimensions of the nitinol plate, even the meshwork what it has been generated on the nitinol plate, or it may be a nitinol sheet, the expansion and as well as the contraction, because of that the mesh size can also be increased and as well as decreased, by which the filtering can also be done very easily. The cryofit is a one example, or the coupling is another example where the repair of the oil lines in the case of the emergency. As we know that in the case of the lines where the oil is flowing or the gas is flowing, it is very difficult to do a welding or some operation which may lead to a hazardous. In such cases what they are doing is they are using a coupling or something like a C-clamp, top and as well as bottom they are using it, and then afterwards those two is locked by means of a fastener. Once if these two are locked, there is a chances of leakage even if there is a tight fitting also. To avoid or to go for a excessive tight fitting, a small amount of heat to the coupling if it is given means, then automatically the pressure exerted on the tubes or it may be on the line is of maximum, by which the coupling it should be a perfect one. The brace wires for the teeth, nitinol strips, even it is used in the case of the bone joints where the forces are exerted. The nitinol actuated even the stents in the case of the angioplasty are some of the best examples of the shape memory alloy, that too especially nitinol in the case of biomedical applications. Thank you.